Thank you very much for having me, last talk of the day. It's always a pleasure to speak in front of such an audience. And without further ado, I wanted to talk to you about postmortems, but I wanted this talk to get a little bit more personal. Let's see if it works. Yes. So when Jason put out the CFP for the conference, I was raking my brains thinking, what could I talk about? It had to be about monitoring and observability, but it got me to think about, why are we interested in monitoring and observability? Why do we do it? And I think I'm assuming, just like me, the reason why you care about it is because it's a means to an end, and the end is to usually run some kind of service for your customers. And maybe let's quick show of a hand. Who is on call? I mean, not today, but generally speaking. Yeah, okay, got it. So you have the experience. The services that you run, that you spend a lot of time designing and running, they're supposed to run as perfectly as possible, but in reality, they don't. There's always something that goes wrong. And when that happens, you respond to an incident, you fix the problem, you remediate, you do a postmortem, and then you go on with your life, and you know that another one's gonna be coming. And so there's this sort of repetition of in a sense, failure in our professional lives. It's managed, but nonetheless, it's not always pleasant. And so that got me to think, could I talk about failure, and particularly publicly. And initially I was a bit reticent, right? Because it's not something that feels very comfortable. But then I recall that, and I think there are a few data employees in the audience, we tell each other, we tell everybody who joins the company, for instance, that if you join Datadog, a sort of fast-growing company, things will break, systems will break, processes will break, and our jobs are essentially problem fixers. You see something, you say something, you fix it, and you move on to the next thing. So that gave me a bit more confidence in trying to talk to you about failure, essentially. My goal really stated or the goal I set for myself for this talk is, one, in a sense, to share with you so that you could learn the same way we learned about from our past mistakes. Number two is that also, very importantly, that you wouldn't feel alone when you face an incident, an outage, failure. That you feel this sort of kinship of spirit that others in the industry have been there, are there probably at the same time you are, and will be there. And hopefully, by talking about it, more openly than usually it's done, that you feel you could do it yourself. You could repeat what I'm doing, which is talking about incidents and outages, to your peers, so that we as a community can learn. All right, so let me state the stage for a minute. Datadog is, first of all, a very happy sponsor of Monitorama, so thank you, the whole organizing team. And what we do is I'd say, observability as a service. So we're on a platform, and typically we consume things like logs, like traces, like metrics. That's what we do. If you want more details, you can find us downstairs. The title has complex system at scale, and I can say that because a couple of things. One is we consume data from really a lot of different machines. Several millions of hosts send us data every single second, so that's a ton of data. We also have a number of customers. Thank you if you're a customer in the audience, and we have to do that every day. All day long under tight processing deadlines. And so that means that we operate at a reasonable scale. This is not planet scale, Google scale, but it's significant. Another way to think about it is, this is a blurred, but this is a host map. So this is one of our production data center. So each rectangle, quasi-rectangle, is a cluster. So there's a bunch of clusters, and inside each cluster is a little hexagon. Each one represents a machine. So that's, I don't know, hundreds of different clusters. So it's lots of machines, lots of ways to fail, lots of interesting failure modes, and essentially all the time we're discovering new ways things fail, and that's compounded by the fact that we keep updating the software. So. Now, it's not like I didn't count all the postmortems, so I don't know if we're at 1,001, but we've been running in production for about 6 years, and so we're, I think it's a reasonable ballpark. And it's a ballpark because, and it happens because we run a complex system, and you probably run a complex system, and maybe the single definition of a complex system is something that runs in degraded mode. It never runs, maybe when you turn it on for the first second, it's as you designed it, but very quickly entropy sets in and things start to break. And generally speaking, it's invisible to the end user. Sometimes it is, but nonetheless, what you have to deal with is, and what we have to deal with as well, is a system overall that doesn't quite behave as we expect. And so when I say 1,001 incident, an incident is really, it's a deviation that we've considered noteworthy, and that we wanted to document and we wanted to capture. But luckily, few of these incidents translate into customer visible outages. But they exist, they happen, so it's a fact of life, but we do our darnest to keep them as few as possible. Now, it's also 1,001 opportunities to learn. Most incidents, not all, but the vast majority deserve a postmortem. And because we wrote so many, I think we got pretty good at it. I think Jason, in the audience here, has given a talk about running postmortems. It's online. You can hit that URL. Otherwise, you can talk to him. I don't know if he'll give us a sort of reprise live, but I think it describes how we run it. I mean, this is not the only way to run it, but this is nonetheless how we do it. And while we were doing that, it became obvious that, well, it didn't actually become obvious. In the heat of the moment, I didn't see it. But after a while, when you look back, you end up with two perspectives. When you look at all your postmortems, you have on the one hand, you have a spectrum, if you will, of richness of detail. On the one hand of the spectrum, you have each individual postmortem. It's a very detailed narrative. It explains in sort of painstakingly why something happened. It has a list of, I think, maybe the most wanted that was mentioned earlier, or this is for this particular postmortem incident, of severity 2, this is what we shall do to fix it. So that's great, because you need that, because you need to make sure you follow up and you check the action items and you actually implement them, or if you miss them, you capture them somewhere. Sorry, I missed. On the other end of the spectrum, we have the very high-level stuff, and the very high-level stuff is, generally speaking, aggregates and trends. Are we doing better in terms of failure or incidents better this month than last year, or is it trending upwards and downwards? In other words, maybe more pictorially, we end up with, on the left-hand side, this is an actual postmortem from 2 years ago that explains why our intake started to send errors, and it's several pages long with planar graphs. So that's one end of the spectrum. The other end of the spectrum is on the right-hand side, your right-hand side, the volume per day of week, which is, just generally speaking, this is for 2017. And as you can see, it's not a uniform distribution. Wednesdays are worse than weekends. That's, I'm happy to talk about why over beer, but that's actually consistent with some other distributions I've seen, I think, particularly from Facebook. So the problem is we found, well, not we, one of us noticed that something was missing. So between these two extremes, there was nothing. And so one of our engineers decided, sort of in a solo mission, to basically read them all and try to formalize all the anti-patterns, which is all the mistakes we've made, such that they could be accessible without somebody at Datadog having to, to read hundreds of different postmortems. And so it's something that maybe is obvious in hindsight, but in the sort of when you're in the middle of it, it's not. And what we discovered, it's really become a very valuable tool for new hands, people joining the company and kind of figuring out, well, what's this place like? If I'm on call, I'm going to run something in production. What should I be, aware of? What should I, or if I'm going to design a new system, what should I avoid? But also useful for people like me to really understand, how's the system evolving over the years? Like, what class of mistakes are we not making anymore? And what classes of new mistakes are we making? But also, it helped me realize something a little bit deeper. And because as I was putting this talk together, it sort of helped me think about how we talk about failure. First of all, how we talk about failure internally. And even internally in a friendly audience, it's hard. It's difficult. And that's because I think at the core, we as social animals are really wired. We don't want to disappoint particularly friendly people. So that means, for instance, that facing and acknowledging failure is difficult. This is emotionally difficult. You have to say, I screwed up. This one's on me, and it's never pleasant. And we make it a point to educate ourselves, to train ourselves to learn that as a skill, and to feel like this is along the line of the blameless postmortem. But I think it's not enough to say we just do blameless postmortem. You actually have to do. You have to. It's repetition that makes you better and makes you feel like let go of your ego. It's like, yep, this is why it happened. Maybe it's me, and I personally was responsible for a number of incidents, so I can relate. And ultimately, the reason why we want to invest in talking about failure internally is because this is an altruistic effort of collective learning. As everybody chips in, such that the group learns and gets better. Now, what I'm doing now, in a sense, maybe in a meta fashion, but I also found that talking about failure in a public fashion is even harder. It's hard, of course, from an emotional point of view, it's difficult. But when I read public postmortems, I've authored some of ours. I read others in the community. I can both relate to how hard it is, and I seldom find them very satisfactory, because on the one hand, they serve multiple purposes. On the one hand, it's about apologizing and sorry we screwed up, we'll let you down, Mr. and Mrs. Customer. On the other hand, you want to show the path forward. So you have to reconcile both in one document. And then you're talking to an audience who doesn't have a lot of context. And so you're either providing too much detail and it's like, oh my God, I have no idea what you're telling me, or too little detail, it's very abstract, it's like this failed and that failed. It's like, okay, well, I've got to trust you because I don't understand what you're talking about. So that I find that medium to be it's difficult to master, and it's not very satisfactory. So what that engineer is trying to do, and what I'm trying to do to you, again, in a slightly different fashion, is to distill failure to its finest essence, as it were, which is really to forget about the specifics of what happened, focus on the patterns. And this is how you do it. In our case, that engineer initially was joined by a group of others, is to look at the recurring themes in the why section of the postmortem. It's like, this failed because, I don't know, configuration was wrong. Well, how many postmortems do we have? How many incidents do we have where we messed up configuration? And it's not only finding the recurring themes, also simplifying. Just cut out the details that don't matter. And lastly but keep just enough context so that if you join the company, you pick up the document, you read through, it's like, oh, okay, yes, I think I get it. You weren't there, but you still can't understand, and that's I think is important. So with that little introduction, I wanted to cover a little bit to give you my distillation of the finest mistakes we've made, as it were, They cover a number of categories, and hopefully, it'll be useful to you. It's certainly been useful to us to write it down and confront them. You may recognize some of yours as well, and that's totally okay. I think that's the whole point. So we cover, in the interest of time, I can't go through everything because there's a number of anti-patterns. But what I figured I'd do is we take the big categories we have, which is configuration, dependency management, deployment, development, observability, operations, performance, and routing, and pick maybe the most interesting one, the one that maybe I remember fondly because I was directly involved, or that's the sneakiest, or things like that. And I'm happy to talk about others, when there's more time. Let's talk about configuration. So, of course, configuration, we've made our share of mistake. We've run the command on the wrong environment. We've done what's usually done with configuration. One of the ones that I found particularly sneaky was for us to assume that when we made a change in configuration, it was always picked up and it was immediately picked up, which, depending on the system you have, may be true or not true. In our case, especially given the scale, it's not. So we use Git-based configuration. There's a workflow. It is different, but fundamentally, you look at Git and you make your changes on a file, and it gets propagated to an environment, and changes happen. And so in that case, we make the change, we merge it, and in our minds, in the minds of at least the team that applied it in this case, it means, all right, it's live. It's on. It's on across the entire cluster. Maybe they're touching, except it's not, because in this case, the system the particular process they were touching didn't have a reload upon configuration change. So what happens is, you execute your thing, you test it, it's like, yep, works, the process is still running, we're processing great, and then 3 weeks later, it just blows up. You're like, what the hell happened? Like, we didn't change anything. It's because immediately, did we change something? Did somebody change something? Did anybody change something? It's like, nope, didn't change anything. And so we fixed the problem and realized that that configuration hadn't been applied for 3 weeks. It was there, it was on disk, but just the process hadn't been picked up because some of the processes had been restarted and reloaded, but some hadn't, and that there were the ones crashing. So in terms of remediation, some of the things we thought about is, well, we should be able to look at a hash, maybe an identifier of the configuration that's live now. We should be able to interrogate the process or the service about what configuration are you running. So that's the sneakiest configuration one we had. In terms of dependency management, timeouts is something that I think we still struggle with to some extent, which is when you have a very complex asynchronous microservices fully distributed system, how do you set your timeouts? In particular, when different teams are responsible for different pieces, how do you set timeouts? And so we've had the case where, and the numbers don't really matter, but fundamentally, you have a load balancer that times out after 10 seconds. And so, but it's sending its requests downstream to a system that times out after 60 seconds. And what happens is somebody sends an expensive request, as they should, for performance reasons, which is not the object of this particular one. It doesn't complete in 10 seconds. The load balancer tells the client, sorry, it's not going to work, or maybe it retries on another node. But as it retries the expensive core on another node, they run for a full 60 seconds. And so they start piling up, and your load starts to increase because the timeouts are not set properly. And so obviously there's discipline. I wouldn't say it's not art, it's not quite science, I think it's not formalized properly, but there's discipline in setting timeouts. And this is where I think as different teams have to come together to really say, well, this is the end-to-end. When you trace something, the client expects a response within 300 milliseconds, a second, 10 seconds, 60 seconds, doesn't matter. So we have to allocate that budget wisely downstream. Another class of problems we've seen in terms of deployment, this is more of a cultural problem, which is to say uptime means victory. More than once, I've heard somebody say in the team, after a system crashed or misbehaved, but it ran for like 3 days or 7 days or 2 weeks, you just pick your number. It ran fine. And so I don't understand. And yeah, that makes sense, because like our brains, for efficiency's sake, are wired to think that what happened in the past is an indication of what's going to happen in the future. The problem, and that's something we can't change, that's how we are. The problem is when we make that cognitive shortcut of it ran for 3 days in production, thus we good, victory. And we forget that, no, it really runs in production, and it's victory when you formally asserted that, yes, whatever change I'm applying is working. It's in place and it's working. And so that's sanity checks you could do manually, not recommended, but nonetheless better than nothing, or in an automated fashion. It's not going to be perfect, but it's better than, yeah, it ran, so we're good. In terms of development, yes, time, probably, volumes of literature have been written about time. Mine is a lot more prosaic. We had a case in, I think, 3-4 years ago. So we have an agent that collects data, and it had a bug. It's a bug that manifests itself only once a year on the daylight savings time. And what happened is we made a change where timestamps in an internal queue moved from UTC to a timestamp that's sensitive to daylight savings. So I think it's usually at 3 a.m., you rewind back to 2 a.m. And so for an entire hour, the queue was like, well, timestamp in the future, I'm not going to flush because the time to flush has not happened. And so you had a blank for an hour where the agent that was affected by the bug just stayed silent. And then all of a sudden at 3 a.m., boom, everything restarts. It's particularly tough because you don't think about daylight savings. The other problem that you see, leap years and time zones, and these are fiendishly tricky problems. It's relatively difficult to, it's not difficult to simulate, it's tedious to simulate. You don't want to, nobody wants to say, oh, I'm going to write a test case that pretends that this is, a leap year and this is the 29th of February, and et cetera, et cetera, et cetera. So, what we do obviously is we try to make sure we default everything to UTC except when it comes to the UI. But that's one that I found particularly amusing. Well, amusing is not the right word, but intellectually interesting, I should say. In terms of observability, so they're the common, we don't have metrics or logs or traces, or we have too many, and so how do we? So these are common. The one that I like is to focus, or when we don't focus on the tail end of a particular distribution, let's say latency in this case. And so you look at your distribution, there's a lot of examples and statistics where you have distributions that have the same moments. They don't have the same shape at all, but if you look at certain aggregates, it's exactly the same values. In our case, even without being so specific, you could have something that the median's great, the 99th percentile is great, and as an engineer, it's like, yeah, my system works. We hit 1 million QPS on our ingest, or whatever, and so yes, only 10 out of this million is slow. The problem is there could be the most valuable ones, and just the distribution, just looking at the distributions is not enough. So what we ended up doing there is to actually, especially for really the tail end of the distribution, the 0.9999 percentile, is you look at every single request and you try to figure out why is it slow, and does it matter? Maybe it's inconsequential. It's slow and it's fine, or it's actually super important. It's like the critical piece of data your customer is trying to get, and they're missing it. So that's something we've started to work. We've worked more in our system. Operations, we've had cases what's internally the set of death. We know internally, which is so you push out new code and you realize, so you pass tests and so on, but you realize something is broken and you're like, oh shit, the service is going down. What do we do now? And we've had cases before we start to invest more in it where we'd spend minutes arguing, well, should we roll back? So that is to say, take the binary that's on disk, the old one, and restart it, or should we roll forward? We patch the code and run it through the entire deploy pipeline and restart everything. And then minutes will elapse. We're like, well, what's going to be the fastest? What's going to be the fastest? And somebody hacked some parallel SSH set everywhere and say, okay, this is while you guys were talking, I fixed it. But that's mistakes we made. And so what we decided there is to pick one rollout strategy. It could be blue-green, it could be pick something, invest heavily in tooling so that you can get really quick. You make the decision and it's done. And you're not like, oh, yes, but it failed at step 5, so now we have to go manual. So you have to invest, make sure it works. That's essential because you're going to face those decisions all. I mean, we faced them a number of times. I'm sure you faced them too. In terms of performance, I think another favorite of mine is resource limits. And so this is the 640K for DOS. This is 65,000 connections on the load balancer or whatever. The problem with that is that we've seen, and it makes sense on paper to set resource limits. The problem is either they're outdated or they're like this. Because it's really hard to figure out what the level should be. Should it be 1 million requests, concurrent requests per second, or should it be half? And you don't know unless you've empirically built a model, validated it, so it's a lot of work. And so in absence of that, you can't do that for everything. What we advocate internally is let go of your resource limits. You have physical resource limits. Your CPU is finite, your memory is finite, your network and I/O is finite. The system, let the chips fall where they may. The systems, as you push it, will behave in certain ways which you cannot predict. Either you load test, again, empirically, you verify and you validate that, or you can't forecast it. It's too complex. There's too many interactions going on. So we've sort of grown past that. And lastly, in terms of routing, this is another sneaky one of retries. A lot of particularly traffic routing systems have reasonably basic retry policies, which is try 3 times. Wait. You can do a little bit of add a little bit of jitter, makes exponential backoff, but finally retry 3 times. Which the problem with that is sort of completely disregard the state of the system, and we've had cases where it makes things worse because we've had connection. In this case, packet loss on initial connection from a load balancer to something downstream. And it would get the initial connection, but then it wouldn't get the response back, so it retry again. And so it would, instead of sending once, traffic roughly once 1x, we'd get 2x, 2 to 3x traffic. And of course, downstream, we unless you provision for over-provision to 3x, it's really difficult to survive that. So we had and so that concludes my little anthology of anti-patterns. The one meta thing I wanted to add is, the 3 things actually, I think, matter in case when facing failures are relatively simple. One is, we forget that, but one is we need to remember to breathe. It lowers the stress level, makes things a lot easier. And it's, you get caught up, you're like, and your brain is deprived of valuable oxygen. Number 2 is you want to stay positive. It's natural, the world's on fire, it's like, shit, that's it, we're done, game over. You want to stay positive because that's the only thing you could do, and it's very contagious. Just like being negative is very contagious. Number 3 is write it down. Whatever you do, write it down. That's hard doing incidents, but write it down. Write a postmortem because it'll help you clarify your thinking. I've thought I got the root cause right for some things, and when I write down, it's like, it's not quite right. There's a non sequitur here which I should fix, and I need to go back. So, That's essentially it. My goal, again, I wanted to recap, and hopefully I've attained a little bit of that. Number one is, have you learned from past mistakes, in our case, in this case, ours. Number two is feel that you're not alone. I think everybody who's been in this industry long enough has faced roughly the same thing, has faced the stress, the pressure, but also the difficulty to talk about it, and so you're not alone. And number three, I hope that I can incite some of you to do the same around you, maybe in the audience, not now, but later after beers, when it's a bit easier to talk about disaster or simple incidents. And that's it. Thank you very much. And we're hiring.